warm-blooded.
I don't want to be warm-blooded.
Where is my presentation? Do I not have it up? No, it's right here. There it is. Oh, I did it again. McKinley, go up, get the homework sheet, because I'm not going.
Doesn't this mean they're equal? Homework sheet.
Yeah. Because I'm not gonna, I didn't transfer the one to the honors one, and so
No, McKinley, up there on the board. Look what the homework is.
Oh. It is. Today's Thursday, right?
Well, let's grade the homework first, and then we'll talk about it. This was not your homework. Pull that down, bring it back to your desk.
It's page 3.
No, bring it back to your desk.
We just had a worksheet.
Oh, that's right. You just had a worksheet. So I'm not collecting that because it was a worksheet. Now I'm on tracking. We're gonna do 9.5 today. 9.5B is a practice that you got to practice these inscribed. Right? You're gonna see they're a little bit more complicated. Here's not your homework. Your homework is McKinley.
Exact same except
1 through 14 all. So Ben, did you hear that?
Wait, what's your 15? Am I telling the truth? Yeah, you just have to figure out.
It better be 1 through 14 or I'll take points away.
What is it?
9.5A.
1 through 14.
Ben, are you up? Maybe he's up and there's something wrong with my audio.
Maybe he wants to go back to bed.
I would.
Hello.
All right, homework is 1 through 14 all, not 1 through 12 all.
Hello.
Hi.
Hello.
Hi.
And
You guys want to see my story?
Yes.
It's a really sad. It's really violent, honestly. You showed us a
Miss-
and it's about people dying.
Mr. C,
What?
Mr. C, you need to see it.
What do you mean see it?
He put that up.
My story.
All right, if we have time at the end, yes, we'll look at it.
He kept popping it up.
Okay.
All right, Madison, that's for you as well, too. The homework is 1 through 14 all, not 1 through 12 all. All right.
Pause it and skip forward 15 seconds when he shows it.
All right, here we go. Inscribed angles. Now I kind of gave in this one away. But there's many concepts today. Each one is very simple. You put them all together, and it gets a little bit confusing because there's so many of these things. The nice thing is that today is an easier one, but there is a little bit of confusion with today's one. I'll try to explain it to you. So recall this. We have got a circle. We have a center of a circle. If I put 2 rays coming from the circle, I make a
Radical.
what?
A diameter.
No, not in this case.
A radius. A radius.
Well, there are 2 radii. What else we got?
A diameter.
There's no diameter.
Yes, it's going straight. No, it's going right underneath it. It's an arc.
We have an arc. In fact, we have 2 arcs
We have
created by this shape,
yeah.
major and a minor. What else do we have?
A chord.
No, there's no chords there.
It's a clock thing.
It does look like it's 2 o'clock or 2:30.
Central angle.
We got a central angle. And remember, a central angle equals the arc. All right. So if you have that construction right there, and that's angle 1, then angle 1 equals
Central.
angle 1 in this particular would equal arc AB. Okay. There we go. All right. Here comes the new stuff. Here we go. So the first idea is this. We still start off with, in the whole chapter circles, we start off with a circle, but this time instead of the central angle being in the middle, well, then therefore it's not a central angle, we put the vertex on the circle. I've already said it a couple times, McKinley, this is called a
Arc. Bird. It's a thing.
the angle is called a,
Oh.
we talked about this section 9.1.
A fetus.
When something is inside something else, we call it,
A fetus.
no,
Technically, if it's a person.
right, we call it an inscribed something. So what is this, an inscribed?
Technically, it's an inscribed cone.
No, that would be 3 dimensions.
That's it. What's it called then?
Well, what's on the inside? What's the shape?
It's an angle.
So
what
it's
is
called
it?
a,
inscribed angle.
it's called an inscribed,
What is the shape?
literally.
It's like an ice cream cone thing. What is it?
Yeah, but that, Even a pizza
It's a
slice is in
cone,
3
isn't it?
dimensions. We're in 2 dimensions.
But it's a two-dimensional cone.
That would be an angle.
What? It'd be an angle connected by an arc.
Right. If you literally cut a cone and took a slice out of it, would make a triangle. All right. Inscribed angle. Inscribed angle. Now,
No, it wouldn't make a triangle because
Oh, my
it's
word.
curved at the top.
oh my word. Where's my cone? Give me a piece of paper.
No, not that kind of cone.
That's a cone.
All right, that's not what I meant then.
If you put the slice right through it, what would it make? A triangle.
Then
All right.
it's-
Hey,
does that
that was
shape
worth the
mean?
$30 it took to
what
buy
does
that this
shape
summer.
mean?
All right.
does that
Write this
say?
down. In Book of Truth, inscribed angle. Remember, inscribed is the thing inside, circumscribed is the thing outside. There's a circle, circumscribes an angle, but the angle is an inscribed angle. The angle whose vertex is on a circle and its sides are chords of the circle. So here's a picture. Here's 2 of them. 2 of them. Inscribed angles.
Not the right. No, it's not right.
It could be.
It's almost right angle according to their.
Well, let's wait till we get there.
No, corollary 2.
Let's wait till we get there.
What if I don't like?
Clearly in red here, they're trying to show you that inscribed angles also make arcs. Here's a minor arc, here's a major arc. Okay, so that's an inscribed angle that makes a minor arc. There's an inscribed angle that makes a major arc. You can also have an inscribed angle that makes a semicircle as well too. All right, we good? All right. So quick note. Now, the book brings this up. I will say we will eventually get to a proof where we have to talk about these 3 things. They're just kind of introducing yourself to this. If your arc, one of the inscribed angle, sorry, if your inscribed angle, one of the rays goes through the center, what can you say about the arc?
Then you can say that the arc is. Do you want me to tell you, or do you want me to wait?
The arc must be, take a guess.
Do you want me to? I thought you were ahead.
The arc must be, if one of the rays goes through the center, then the arc must be. No, it's got to be minor. There's no way to get a major arc with an inscribed angle if one of the rays goes through the center.
You could have a major arc ABC. No, you can't because it's split. That's fine. Good job. Yep.
Thank you for agreeing. All right, next construction. What happens if neither of the 2 rays goes through the center? What kind of arc would it make? Would it always be a major arc? Clearly AC is a, so would it always be a major arc? Could it be a major arc? Could be. So if neither of the rays goes to the center, then we say, right, it could be major, minor, also could be a semicircle as well too. Okay. All right. So major or minor. And then lastly, if neither of the 2 rays goes through the center and they're on one side of the center, take a guess. The arc, you put both of the rays on one side of the center, then the arc must be, there's no way to get a major arc. You put both rays on that side.
So it's just equal to less.
Okay. And it will be. And we're gonna, and it comes up in proof by cases, because we're gonna have to make a statement sooner or later about this stuff. And we'll have to consider all 3 cases. All right, cool. But what is this good for? Well, it's good for, we got to prove something. All right, McKinley, look at the shape. Tell me what you see.
It's only a minor.
Well, we got a minor. What else do you see on the picture?
I see a chord AB and chord BC.
So 2 chords, it's an inscribed angle. So I see an inscribed angle. What are we trying to prove?
That measurement to ABC equals half.
Yeah, but measurement of what?
Angle.
So the measurement of angle, the inscribed angle, is equal to of the
Arc
that it
AB.
makes.
Yeah.
So the angle is equal to half of the arc that it makes. All right, that's what we're trying to prove. And since Jack already spoiled it because he's looking at his book, right? I'm gonna once again rely on the other three and four counting Ben, right? Any ideas of something we could do?
Yes. I have ideas.
Because you're looking at the proof right now.
I have so many ideas.
Any ideas?
Let's see, we can,
Well, how would we make a triangle?
Make chord AC.
Make what?
Chord AC.
Yeah, that would give us one triangle. There's another way to make a triangle. That's the one I'm going to pick, right? So I'm going to make I'm going to make radius OA. And that's where we're going with this. Kinley, you see the isosceles triangle?
yes,
Why is it isosceles?
because of bottom and sides are equal.
Why?
Because of theorem.
No,
6.3.
why?
Uh,
Just look at the picture.
because they're clearly look that way.
We can't use that in geometry.
Why?
Why is OA and OB congruent?
Oh, radius.
They're radii.
Yeah.
All right, let me catch up. So OA is congruent to OB. They're both radii. Therefore, we can say that it is an isosceles triangle. Okay, that's what I'm going to do. And it's the next step that's kind of the more, wait, what do we do now? All right, we haven't used this one in a while. Draw a triangle. What do you know about angles 1, 2, and 3?
What did we do to 2 plus 3?
Why?
Because of the external.
Remember that? Look at our shape. And what can we say?
That angle AOC is congruent
Is equal to,
to BAO plus AB.
wait a minute, OAB and ABO are exactly the same. So yeah, that's equal to this one plus this one, but they're both the same. Suspiciously, I'm going to choose this one because that's what I need. I need angle ABC. So 2 of ABCs would be equal to 1 AOC. Why? Well, it's really comes from the fact that the external, that 1 AOC is equal to OAB plus ABO. All right, McKinley, look what we got. I got an ABC, I got an ABC. I got an AOC, wait, I got an AC. I got a 2, I got a half.
So
Can you change a 2 into a half?
multiply 2?
Not multiply.
Divide.
Let's divide both sides by 2. So now I've got left side equals left side, right side, well, they're close, but one says AOC and one says AC. One says AOC.
Substitution.
What am I substituting?
You're getting rid of C or something.
Yeah, but why can I do that substitution? It's a central angle. AOC is the central angle that makes the arc AC, so therefore it's a simple substitution. Okay? QED.
Yeah, I did it.
McKinley, what did you prove?
That's
If you have
whatever this thing is called,
inscribed angle,
inscribed angle, if you have it, then and one
it's equal to
a half of the arc.
the arc that it makes.
Yes.
All right, that's theorem whatever. 9-7. The measure of the inscribed angle of a circle is equal to 1/2 of the intercepted arc. Fancy words for the arc that it makes. Here's 3 different pictures, the same 3 pictures I used before. So if ABC is an inscribed angle on circle O, then it's equal to 1/2 of AC. And here's where the confusion is. Why is this confusing? McKinley? Why is that form of confusion? It looks pretty simple.
Because sometimes angle?
Uh,
Don't think that would.
sometimes they look at the middle one.
Oh,
If I just gave you the middle one and you forgot which one is half, it would be hard to figure out which one gets the half.
right.
I mean, even on this one to the far right, it's kind of, okay, little angle, little arc, right? So for most students who can't get this memorized or usefully memorized, their problem is that they can't remember which side gets the half. I'm gonna show you two ways to remember this. Okay, now clearly I gave you a third, you can have the book of truth. But when you take that, NWEA test, this one's on it, and you're like, oh yeah, that's the one that's a half. Now, which was the half? Here's how you remember it. Hey, how do you spell angle? How do you spell arc? It's alphabetical. So the angle is equal to half of the arc. Alphabetically, the angle is equal to half of the arc. The angle is equal to half of the arc. Like I said, I see this all the time. It's not that you forget that there's a half involved. You just forget where the half goes. Jack, what's another way of writing this formula?
Another way of writing that for you?
Yeah.
2ABC equals
2 of the angles equals an arc. If you want to write that way, that's fine as well too. So 2 of the inscribed angles equals the arc. But boy, will this cause confusion. So here, I'll give you a third way of remembering it. Okay. If you really truly are taking a test and you've forgotten which is the half, and you're like, oh, I know this is an easy one, I should be able to get it, but I can't remember, draw yourself a circle, make yourself a diameter. Okay. So I have major arc ACB right here, right, or semicircle arc ACB. How many degrees are in that arc? If that's a diameter, it's 180. Now let's make the inscribed angle that will connect those endpoints. If I make an inscribed angle that goes from here to here to here, and I look at the angle, it's a right angle, right? Clearly, if you know there to there is 180, well, which one is half? And you're like, well, maybe it's the angle that's half, and that angle would have to be 360 if they were half. That doesn't make any sense. So therefore, it's got to be half of the arc. Now it kind of makes sense. And oh, by the way, I just proved corollary something or other.
Oh, okay. Oh, corollary 2.
Corollary 2?
Did you already write down corollary?
No. I'm just saying what happens is the kid will forget which one is the half. Is it the angle or is it the arc that's half if it's described? So for me, this is what, say, I never even thought about the alphabetical thing. I just would draw a quick picture like, wait, is it the arc that's half or is it the angle that's half? I would draw this picture like, oh, it's got to be the angle, because otherwise, if it was the arc that was half, that would make the angle 360 degrees, and that would be a circle, not an angle. All right. Now, everybody put your pencils down. These cause problems. Let me help you with the problem. These are very complex pictures, and the way that you solve this is you declutter the picture. In other words, in your mind's eye, or maybe you draw it, you kind of erase things to make it easier. McKinley, what colors do you see there?
Blue and red.
All right. Do you want to solve for X or do you want to solve for Y?
Y.
Okay. Thank you for choosing X. All right.
What? Oh, okay.
You'll find out the Y you need to solve for X first. Okay, let's look at X. What color is X?
Red.
Now, I'm not going to say that this always works. Ignore the blue. Just ignore the blue. What do you see?
I see that PTQ X makes up PTQ. The 40 degrees.
That's the picture if we ignore the blue, and therefore you should be able to now tell that it's
the thing we just did.
it is the thing we just did. So read the thing we just did.
The measure of an inscribed angle.
The measure of the inscribed angle is
equal to half the intercepted arc.
So where's the arc?
Or there.
So therefore X is?
It's half of that, so 20.
See what I mean? I mean, there's a lot of stuff going on. This can be overwhelming to some students who are like, I don't even know where to start. There's too many lines. Maybe there's a diameter. I don't know. It's confusing. So sometimes just decluttering the picture is all you need to do. If I declutter that picture and just think about what's written in red, okay, sure, we still got a Y there. But for the X, it's really clear that it's just 20. So if X is 20, now we gotta, Allie, we gotta do Y.
Oh, so why? So you would have to go to the angle P
So-
R.
So now we're gonna declutter the red and just think about blue. If we just think about blue, it looks like this with a 50. So if the inscribed angle is 50, then the arc is, and the arc is made up of two pieces, one being 40, which would mean Y would have to be,
Oh, 60, yes.
you got that
Yeah,
part?
I got that.
And I'm just gonna say, I will generally put something like that on the test, and I will literally have kids miss this, when in fact, it's not that challenging of a problem. But the reason why students don't get it, at least in my opinion, is it's just too much stuff going on at once. So try to declutter the picture to give yourself a little bit more help. Everybody good on that? Ben, you good on that one?
Why did you solve X? I could have done that without X.
I'm good on that one.
You could, but the X was the easy one. Like, it was really one step. This one was two steps.
Okay. If you have three sides of a quadrilateral that are congruent, can you have one side that's not congruent to it?
Sure. I mean, we don't call it a scaling quadrilateral, but you certainly can. Okay, write this one down. I'll prove it to you real quick. Hey, declutter the picture. Just look at the red. If angle 1 is 40, how big is the arc? Declutter the picture. Just look at red. If angle 1 is 40, how big is AB?
Maybe.
Now declutter the picture. If angle 2 is 40, how big is AB?
80.
Why are they both answers 80?
Because they intersect.
The same.
They talk about literally the same arc. I just proved it for you. A pretty weak proof because I used numbers. You can't use numbers in a proof, but we can assign a value and prove that it's the same. Yeah, but if two inscribed angles intercept the same arc, in other words, they make the same arc, well then they have to be congruent. Okay, that was a pretty easy one. Now I did do a good proof on the corollary too. Tell me when you're ready. Yep.
Yeah.
Okay. I did do this one. If MN is a diameter and this is an inscribed angle, remember the angle is equal to a half of the arc. So if MN is a diameter, then arc MN is 180 degrees. Well, that would mean that angle MXN has to, or the inscribed angle has to be 90. So that's all it's saying. If your inscribed angle, or if your angle that's inscribed creates a semicircle, well, the only way that happens is if the angle is right. I don't think did I sign that for any proofs for homework tonight?
I don't think do we have proofs tonight?
Well, I'm just saying that, I mean, anytime we have,
10, 11, and 13, and 14.
but they're not these, right? It's not proof corollary 1, 2, or 3. Okay, good. Because these are just too easy.
What if I don't want to make
Yeah.
Wait, so it's
don't make
the measure for the inscribed angle and the arc that's half of
Just think about it alphabetically. What comes first, angle or arc? The angle is equal to half of the arc. The angle is equal to half the arc. The angle is equal to half the arc is 180. Half of 180 is 90.
I think you said it the other way.
I'm pretty sure I said it. I could have.
When you were explaining like the half like that, I think you said we couldn't have half of the arc. I don't know.
I think what I was saying was, if it was the other way around, right? If it was the if it was double the other way around, so we double 90, we get 180. If you double 180, you get 360, right? So if it was I'll say it right now, if the arc is half of the angle, right? And that would make that angle 360. If the angle, or instead of it being what it is, which is the angle is half of the arc. I could have said it backwards. All right, so this is the one that Jack was struggling over.
No, I know what this one is.
Let me show it to you.
Oh,
All right, everybody got to pay attention. Ready? I want you to look at point E and G. E and G. E and G is made from what inscribed angle? What inscribed angle makes EG?
oh,
Oh.
Well, okay. But it's also made by, one goes in this direction, the other one goes in this direction. How many degrees? But the angle is equal to half of the arc. And if the two arcs together is 360, then the two angles together must be. And what do you know about a relationship when two angles together equals 180? We call it. With two angles together, we get 180. We call those angles. Nope. Supplementary. So here's the, and this is kind of surprising that this actually works, but it does. In fact, we just proved it. Is that if you have a quadrilateral, and it's any quadrilateral, it could be a square, it could be a rectangle, it could be a kite, it could be any quadrilateral that's inscribed in a circle, then it's not adjacent, but opposite angles are supplementary. That means angle H plus angle F equals 180, or angle E plus angle G equals 180, either one. A fairly surprising result. However, easily proven, as I did before. And remember, all these are corollaries because they come directly from the fact that the angle is equal to half of the arc. We're not saying that E and H, if you add them together, you make 180. That's true for some quadrilaterals, squares, rectangles, right trapezoids for one of the sides, parallelograms, it's true for. But for all quadrilaterals, if you inscribe it in a circle, then opposite angles are supplementary. Okay, cool. All right, this one is going to be challenging. Once again, it's going to be a very messy picture, but it's a really pretty easy problem. All right, McKinley, you're up. What do you see?
I see the intersection.
Okay, there's definitely an intersection of blue lines. What else do you see?
I see art.
Big shapes, big shapes.
Oh, big shapes. I see measurements ABC and AD.
Big shapes.
The square.
It doesn't look like a square. It could be, I guess.
Hexagon.
There is not a hexagon there.
Polygon.
What kind of polygon?
Quadrilateral.
And what did we just learn about quadrilaterals that are inscribed in circles?
They all equal 180.
The opposite angles added together equal 180.
Yes.
What? Give me the opposite angles of that quadrilateral.
40 and 30.
No. The angle, names of their angles.
Oh, but angle ADB.
ADB is not an angle of it. I want the whole angle. The whole angle.
I don't see any other angle, but it's 40 and ADB.
There's the quadrilateral. That's the angle. What's the name of that angle?
A.
A is not descriptive enough.
Oh. That would be A. That's angle
It's
A.
not descriptive. There's 1, 2, 3 angles there. They all have an A next to them. I need a descriptive
BAD.
angle that says this whole thing right here.
BAD.
BAD. And that plus what other angle equals 180?
ECB.
Okay, that's the idea. All right. Typically, when you get a really messy picture like this, and there's 3 things one at a time. Yeah. BCA. Where is BCA? BCA is this sucker right here. I'll say, I have students look at this for hours and not figure it out. Because there's a lot of stuff going on there. What was the technique we used in the previous? When they're really messy, what should we do with our eyeball? Block everything else, try to just focus on just that one little piece. So over here, I'm going to redraw it. Here's the circle. We're trying to find BCA. BCA is right there. Great. So that means it makes that arc right there.
It's
You ready for the magic?
40.
Well, why is it 40?
Because arc AB would be 80.
There you go. Because there's another arc that describes that same arc, and it's labeled as 40. So if that one's 40, since this arc is also created by inscribed angle BCA, then it also must be 40. McKinley, yes or no?
Yeah.
Okay, cool. And then what is that corollary? Corollary 1?
yeah.
Okay. Done. Now we got to go to ABC. Angle ABC. What do you think, Alec?
So ABC. Well, you know that ABC has to be 90 because it makes a semicircle.
Makes a semicircle, cuts through, it makes that diameter right there, so it's got to be 90. So the whole thing right there has got to be 90. All right, halfway there, now we got BAD. Who's left? Jack? BAD?
BAD equals 110.
Where are you getting that from?
Because it's supplementary to BCD, which
And that is,
70.
I'm sorry?
70.
And that is 70. You see that? So if that's 70 and those two are supplementary, then it's got to be 110. Okay. This is usually the one that I get the most groans of pain from, is that they don't see that there was a diameter involved right here. And they'll look at it for hours. I mean, literally this one for hours, and they won't see that. And then I finally say, hey, look, it's a diameter. And they're like, oh, okay, I see it now. All right, that was pretty good. Ben, questions?
Nope. Actually, I do have a question. Can I show you my story?
Let me see if I'm done yet.
You have one more theorem to prove.
We got one last thing. Think about this. Okay, everybody look at the board. You got a T, you got an A, you got an inscribed angle, ATB, right? Here's what I'm going to do. I'm going to progressively move the ray TB more and more and more and more and more until it's no longer an inscribed angle, it's a tangent. Okay, I'm just showing you it's getting larger and larger. Eventually, it's a tangent. Now, we've seen something like this sort of before, except before the tangent was created from the center, right? We know that's 90 degrees. Well, how big is that?
More than less than 90.
Well, how much is it?
As 80.
This will be a little bit surprising result. You've already looked at it.
I know, I've already written it down. 70, 60, 40.
And no, I'm not looking for a literal number. I'm just saying, could we figure out how big that angle is from something that's already on the picture?
You can make a triangle, but I don't see how that would help you.
So it turns out just like an inscribed, this is not an inscribed angle, right? It's an angle, right? It turns out that this one is also equal to, take a guess.
Half of AB.
So this one, right? And you can get the same idea from this one. If we extend this one up here, the arc that it makes is how many degrees? And therefore, that's why this one is 90. So take a guess.
So it's half of 80.
It's half of the half of the arc that it makes. Okay, and this is theorem 9.8, and the last one.
No, my thing.
Maybe tomorrow, Ben.
Oh, now I will put it now.
Thank God you're in 9th grade, Ben.
What is that supposed to mean?
Anything with 8.
You're giving me the reaction I would expect from my next period.
It's there.
Good
It's
try.
here. Story. Wait, did it not? There it is. Story.
Thank you for interrupting my theorem 9.8.
You're welcome. All right. Goodbye. Have a nice day.
The
You
bullies
as well,
die
Ben.
and get choked out.
No, they don't. That's baloney.
Well, okay, the bullies die. It ends with someone.
All right, Ben, we're stopping.